people from the rest of the world think that New Zealand and Australia has a similar accent, but to us, we can make jokes about each other and the accents. Anyway, so level up and level start. Level start is the prefix that all the level up plugins are published under. So everything that's level dash is a level plugin. So level start is like the name for the ecosystem. So a bit of philosophy. So you may have heard of the Unix philosophy. Who's heard of the Unix philosophy? Yeah, good. So this Unix philosophy is about building many small tools that fit well together, that you can connect them together with pipes, with strings, to communicate with text and so on. But a whole bunch of simple small tools, and each thing does one thing, does it well. And there's this other thing called the Emacs philosophy, which is to build a small, really performant core of your application in C, and then build all the high-level stuff in with flexible dynamic language. In Emacs, this is done in Lisp. But in Node.js, it's JavaScript. And Node.js has both of these things because it has a great package system from NPM. So you can have a whole bunch of tiny modules that do one thing well. And you have the Emacs philosophy because the core of it, where the performance really matters, is in C, and very good C, and everything else is in JavaScript. And even the implementation of that dynamic language is also implemented very well, highly optimized in C. So Node.js is the best of both worlds. Now, level up is the same idea as Node.js. This isn't literal, but basically the same idea. So let's compare what you can do with LevelDB to SQL, obviously. So get a bunch of data. So in LevelDB, you do a string. So you create a string, and you can pass an option for like the start and end point. But that's how you just give me lots of data. So what if you wanted to get data that's changing in real time? This feature doesn't exist in SQL. You have to poll the database. Maybe it would look like this if it did. In Level Up, it looks like this. You use this live stream module, and you ask for a live stream, and that will pull out all the data that exists in that range, and then it will keep the stream open. And when more data is inserted into the database, it will give you that too. So it's perfect for sort of live feeds and that sort of stuff. And this is what really, this is inherently simple to do because Level Up is embedded into your node process. So you can control everything that goes into it and comes out of it. And so you can just intercept whenever something has gone in successfully, and you can just add it to any streams that are currently registered with it. And like this is a feature that hardly any other database has. CouchDB has a changes feed. Has anyone used the changes feed in Couch? Yeah, changes feed in Couch is really good, but I always wanted to have how to do a view in Couch and like tail review and stuff like that. And you can't do that in general. But in LevelDB, you can do that with nearly all the modules. So what if you wanted to get an aggregation of data? And in SQL, it would look like this. LevelDB, we can have MapReduce. So this is a MapReduce module. We pass to the database, we get the MapReduce thing, I'll explain that more shortly. We map it. The data is not parsed for us, it's always, I just always use text, binary rather, and then parse it, emit it. This is basically the same as Couch or Mongo. Add it up, because these are strings, so we need to turn them back into numbers. When you save it, it's turned back into a string by default, so you're okay there. And then you can query it, and you can also tail it which will keep the string open and you'll get live changes. And this is, I didn't try to put this in my slides, but you can group it into various levels. So you could do an aggregation grouped into, say, like city, region, country, and then you can request the data from the aggregation from like at a city level, at a region level, or a country level, or or the empty brackets means like the global level, basically. So also sometimes you need to partition data. You have like products aren't customers. You need a way to handle one thing at a time. So in SQL, you do something like this, and then have a whole bunch of schema options. In LevelDB, you do this. So you use this thing level, sublevel, and you add it to LevelDB. You add it to LevelDB instance, and then you can create a sub-database. Here we have a sub-database called foo, and that returns you a new database instance that has exactly the same API as a standard level up instance and works exactly the same, except that it stores, when you put something into there, it stores it in the big database with a prefix, but it hides, it abstracts away the prefix. So when you put something into FooDB, it has foo attached at the start, and when you do a read stream or something from foo, it will return you all of the things that have foo at the start, but it will handle all of that for you transparently. Interesting thing is that you can create nested regions, nested sublevels. So you can put a sublevel inside a sublevel because it acts just like the whole database. So what if you wanted to, sometimes you need to execute some code, especially when you're doing interesting stuff, you need to execute some code on an insert. So this is one of my favorite SQL features. You can change what the end of line separator is. In fact, you have to. So here we have two nested expressions, and normally SQL ends on a semicolon, but it can't understand that you've nested two. If you use two semicolons here, it would give a syntax error. So you have to tell it to change the delimiter, and then you do create trigger, and the inside one somehow knows that that is that end. I'm not sure if you can nest changing the delimiters. That would be cool. And then you end the old one with the first delimiter, the delimiter that you changed to, and then you change the delimiter back. I don't know. If you want to put up with shit like that, you can use SQL. So, yeah. So here's how you do that in LevelDB. So you have if you're using level sublevel, otherwise you can use this module called hooks, which will do this. So you have a pre-hook, and a pre-hook runs before the batch or the delete or the put as applied to the database. So it will call your function with the change, which is an object just like this, which is the same format as the arguments to the batch operation. And then you can call this add function to add additional operations to the batch. And I think if you call add false, then it will remove the operation that it triggered on. And this is really useful for doing all kinds of stuff. Now this sort of trigger is just for when you want to do a change without doing any layout, when you want to do a synchronous change. Now if you want to do this is a feature. So if you can, with the different sublevels in one database, you can do a pre-hook, and then you can insert, you can have a batch that spans across different subsections of the database. This is extremely useful for making interesting plugins. We'll use that shortly. So here is, say if you needed to trigger asynchronous code that say goes across to the network or something like that. Here's how you do it in SQL. This time we'll use as the delimiter. So here we run an external process that's just going to append a timestamp into a file, and it's going to run after we insert something to fill. Difficult to get any real-time data out of SQL. But we also have this thing in LevelDB called trigger. So we apply it to a database. We give it a name. It needs to not collide with other triggers we might be using. And then we have this callback where we can do some action that can involve arbitrary either. So like we can read from the database, we write to the database, we can request something from the network, we can do whatever, we can do anything we like. We just have to call done when we're finished. And if the database, if the process crashes while we're in the middle of this, when it comes back up, it will rerun the process. So you know that even if your thing crashes occasionally, eventually all your jobs will be consistent and will eventually run. That does bring one requirement, that your job, it may run twice. Like it could complete, but the database could crash, or the process could crash before you've pulled done successfully. So it needs to have no effect if it runs twice. It needs to do the same thing. So what about joins and stuff? People always do joins in SQL, and that's perhaps the one thing that they're really good for. And I think it needs to, something people have so pressure, they call SQL databases get called relational databases quite often. And I think that's really unfair for the rest of the databases, because SQL databases shouldn't own relational. The idea of relations is actually like a mathematical idea from set theory, and SQL is just a particular crude implementation of being able to deal with relations of data. Relations appear everywhere. So, for example, Twitter is basically relational data. You have tweets, and then your view of when you look at your feed is a join, basically, of all the tweets joined to on the people that you're following. Joins shows all their tweets and sorts it by time. So this would be the query if Twitter was implemented like this. It's not implemented directly like this because it wouldn't scale, and it wouldn't be real time. It wouldn't give me the latest updates and stuff like that. So if we were going to do a relational join like this, and LevelDB, how would you do it? So just a bit of the first thing is we've got to structure our data into ranges. So this is actually one of the best features about LevelDB, is the way that things are stored on disk in the sorted string tables. They're sorted in order. So if you set your data, if you save your data, so your data is saved in order, then it means that you can read a whole bunch of records in a single disk set. So it's really fast. Where in other databases, there's no guarantee that your records are stored adjacent. So you may have to read a range, you may have to move the head all over the place. But with LevelDB, reading a bunch of, reading a range of data is just as far, isn't any slower really than, in terms of disk space, than reading a single document. So it's best, it's really, really good to arrange your data so that you have it stored as a range of records rather than a single chunk, because then you can just append to that and it will eventually end up inserted in the same place and you can read it out really quickly. So we have like this tweets table